Hello everyone, welcome to our YouTube channel. Let us proceed further in our journey. Just read the question statement. This question has been asked in your ESC 2017 examination, right? Please read the question statement. So, 12 pole 440 volt 50 hertz 3-phase synchronous motor takes a line current of 100 amperes at 0.8 power factor leading, right? Neglecting the losses, find the torque developed by the motor, right? So you understand the question? So these are the four options A, B, C, D. Out of these four options, only one option is correct. That you have to find out the correct option, right? So let us solve this question. So you have been asked to calculate the torque developed, right? So the very basic relation of the torque developed, torque developed is nothing but the developed power. Let me call it by P developed, PD, right? Developed power divided by synchronous speed in air gap, right? So if you calculate these two parameters, if you calculate these two quantities, that is the developed power and the another one is synchronous speed in air gap, right? Synchronous speed of air gap flux, right? If you calculate these two quantity, you can calculate your developed power, right? So let us suppose this is equation number 1, right? Now your job is to calculate this developed power and the synchronous speed. So this developed power is in watts and the synchronous speed is in radian per second, right? Radian per second. So first of all, let us calculate power. Now see the data which is given to you. He has given you the data of this line current, right? Motor takes a line current of 100 ampere at 0.8 power factor leading. At which voltage? At the supply voltage of 440 volts, right? So with this data, you can calculate the input power, right? P input you can calculate. See, the motor is operating at leading power factor. That means it is in overexcited condition, right? So P input, you can find it out by the given data. P input is nothing but √3 times of, for three phase it is √3 times of V line voltage into the line current, right? And into the power factor, right? So √3 times of line current. What is the line current that is taken by the motor? It is 100 ampere, right? Line current is 100 ampere. And what is voltage VL? Supply voltage is 440 volts. Both are the line values, right? Both are the line values. And the operating power factor is 0.8, right? So now calculate this power, input power. It comes up to be equal to how much? It is equal to your 60966.4. This input power is equal to 60966, right? 60966.4 watts, right? So now see here, this P input that you have calculated, this is nothing but the output developed power, right? P developed, output power, that is developed power, P developed. Why? Because he is saying that you have to neglect the losses. It is given in the question. He is saying that neglecting the losses you have to find the torque developed, right? So that means when you neglect the losses, what are the losses? Losses are like friction and windage loss, O-big losses of the winding. So all these losses when you neglect, then you will find that output developed power is exactly equal to input power, right? So this is 60966.4, right? Now, so one quantity you have calculated. Now calculate omega s, that is synchronous speed, right? So omega s is given by 2 pi ns by 60, right? This is in radian. You have to calculate this in radian per second. It is a speed of air gap flux, right? It is a speed of flux in air gap. So 2 pi by 60, and your ns is the revolution per minute. So ns is 120 f by p, number of poles. F is the supply frequency, p is the number of poles. So when you solve this, you will get 4 pi f by p, right? So f is the supply frequency equal to 50 hertz, p is the number of pole is 12. So when you put this, f is equal to 50 hertz and p is equal to 12 poles, pi is 3.14, you know, and multiply whole by 4, you will get the synchronous speed is equal to, synchronous speed in radian per second is equal to 52.33, right? It is coming out to be 52.33 radian per second, right? 52.33 radian per second. So now you have calculated both the parameters. So now from equation number 1, you can now find out the developed torque. So developed torque is now equal to developed power, which is nothing but input power only, neglecting all the losses, divided by angular synchronous speed of flux in air gap, right? That is omega s 52.33 radian per second. So when you put all these values, that is torque developed equal to power developed. So power developed, you have calculated how much? 60966.4 watts divided by 52.33 radian per second, right? Watts by radian per second. So this is the torque developed, and it is coming out to be equal to 1164.97 Newton meter, right? This is the value of the developed torque. So this is approximately equal to 1165, right? So which option is correct now? Option A is correct, right? 1165 Newton per meter. So your option A is correct, right? Option A is correct. Option A is correct. 1165 Newton meter is the value of developed torque, right? So like this you can approach this question. Okay. So you understand? So you understand the solution, right? So thank you very much. Thanks for watching. So for all such kind of ES and GATE question, you can subscribe the channel. Thanks for watching. Thank you very much.